2 plus 7v3 as a matrix times a vector. This is a very good example to exercise the point that I just mentioned. So place v1, v2, v3 in columns of a matrix A and place the weights 3, minus 5, and 7 into a vector. So this is the matrix. So each column is, for instance, V1 is the first column of the matrix. This is the second column and so forth. And these are the numbers, real numbers. So it constitutes a vector 3, minus 5, and 7. And so the result is A times X. A here, matrix, and this is vector X. Okay, so now write a system of linear equations as a vector equation involving a linear combination of vectors. For instance, the following system. So if you remember in the first couple uh, sections, we were writing these linear equations, and if you have paid attention, this is another notation by using a vector. This is the notation actually. Ax by Ax equals to B. So this is called matrix equation, and that was the linear equation, and we would be seeing another one. So all of them actually are different views uh, of the same thing. The following system, x1 plus 2x2 minus x3 equals 4, minus 5x2 plus 3x3 equals to 1. This is equivalent, very important, this is equivalent to this one, x1 through this vector. This is x1 times 1, 0. So x2, 2 minus 5. So just look at these two, and we would write it as this one, x2 times 2, 1. And this is x1, and the second equation is 0 times x1. And the first one is 1 times x1. So we factorize x1, and then we will be left with 1 and 0. This is 1 and 0 and x1. And for the last one, x3, if we factor out, it would be like 1 minus 1 and 3, minus 1 and 3. And in the right side, 4, 1, 4, 1. So we can go further, and uh, we can have actually these numbers as a matrix: 1, 2, minus 1, 0, minus 5, 3, as we would see in a second. 1, 2, minus 5, 0, minus 5, 3, and this is a vector x1, x2, x3, and this is 4, 1. So this is called the matrix equation. So brothers and sisters, see, we had this equation following system. We converted it as a matrix equation. Just this is another notation, matrix equation. So the same thing. And so this is the theorem number 3, because we had these 3 notations. This is one view, this is the second view, and this is the third view. If A is an m by n matrix with columns A1, A2 through AN, and if B is in Rm, this means that the B is a vector in Rm, then the matrix equation Ax equals to B, we just see that, has the same solution as the vector equation if we write it down as like x1a plus x2a, a2 plus x3 times a3 and so forth equals to b, and both of them have the same solution as the system of linear equations whose augmented matrix. If you remember in the first section, we were discussing about augmented matrix. Augmented matrix A1, A2, A3, and A4, and this is the right side of the equation B. So all of them are equal. Actually, they have the same solution. Three views of the same thing.
قاعد والله شوي حطت لي تقول حبيبي لا صاحبي قاعد
Okay, so I cross this out because it might be misleading here. It is correct, but
لا بالعكس
it might be misleading here. If you go through that, you will realize that. Just forget it. Theorem 4. Let A be an n by n matrix. Then the following statements are logically equivalent. This means that, logically equivalent means if one of them is true, the rest are true, and vice versa. And if one of them, for instance, is false, this means all of them are false. So logically equivalent, this is the meaning. So if for a particular A, either all of them are true or all of them are false. So these are 4 statements which are equivalent, logically equivalent. For each B in Rm, the equation Ax equals to B has a solution, brothers, sisters. Has a solution means it is consistent. So it might have one solution, one or infinite solutions. So it has a solution. Each B in Rm is a linear combination of the columns of A, because we just saw that, if you remember. So see here, B is a linear combination of the columns of A. This is a column A, this is a column A, and so forth. And this is a linear combination of that. And the columns of A span Rm. Span means it covers, it generates Rm. If you don't get it fully, you need to go back and refresh your mind. And A has a pivot position in every row. Can you exercise for each status, please? Can you take exercise for each status, please? We already discussed many of these. For each B in Rm, the equation has a solution. So this means this is a consistent equation. And each B is a linear combination of the columns of A. We just saw that. And the columns of A span Rm. See the columns of A. These are the columns A1, A2, A3, An. So this is going to generate Rm because B is in Rm. See, B is in Rm. And A has a pivot position in every row. What does this mean? Because A actually is a consistent, so this means that A needs to have a pivot position in every row. So just note, a system is inconsistent if AB has a pivot in in the last column. So, but a system is consistent. Here we have this situation. This is because this is a consistent. If it is true, matrix A has a pivot in every row because it cannot have rows like 0, 0, 0, 0, and B, because then B, if B is non-zero, the system will be inconsistent. You need to go through this one once again and refresh your.
Doctor, please, what he mean by the point C, the columns of A span R to the M? What he mean by span?
What do you
Um,
mean?
we had this discussion. Span. Span means it covers. It generates all of the vectors in Rm. A span. If you remember, we had this discussion. For instance, we had it in the previous section.
You mean generate, Doctor? Generate?
Yeah.
Yes, generates. Exactly. A span means generates. So it generates Rm fully because it can generate all of the vectors uh, in this space. For instance, just brothers, just give me a second. So if we are talking about one vector, for instance, u, a span of u means all of these lines. A span. See, all of these lines means the span of u, because it is defined as C as an example, as a scalar times u. So it could be negative, so it would be going in this way, and if it is possible going this way, so it could generate all of these lines. And for instance, if we have two vectors like u and v, for instance, what would be the span of u and v? A span of u and v means all of the, look at this space, for instance, it could generate everything here because the span of u and v is defined as the linear combination of cu plus dv. So it could generate all of these points here in this page. So span means generate. And okay, so, and also you need to pay attention to the last one also. So let's go through some examples. Compute ax where a equals to 2 minus 1, 6, 3, 5, minus 2, 4, minus 3, 8, and x is x1, x2, x3. So computing ax means multiplying matrix A by vector x. So this is very, very, very easy because you need to have the first column. So this is the first column of A times x. And the second column times x2. And the third column times x3. So this is the vector equation that we just saw. So then you can actually have you can have 2x1 minus 1 x1 6 x1, and then you can actually add all of these numbers together. So we are left with this one: 2x1 3x2 4x3 minus x1 5x2 minus 3x3, and so forth. So this is the product of ax, and we would be talking about this later on, but this is a kind of dot product equation. But um, here we won't be. And so, brothers and sisters, see dot product. This means if you multiply two vectors, for instance, 1, 2, 3, this is called dot product. Dot the other vector, for instance, 5, 6, 7. So we are actually going to multiply two vectors as a dot product. So the answer is here 1 times 5 plus 2 times 6
plus
and plus 3 times 7. The answer is a scalar. So if you add all of these ones, 2, 3, 1, 3, 8. I think it is 38. So the result of a dot product of two vectors is a scalar. So this is 38. But we won't be reaching to that point in the first chapter, but I just wanted to clarify that. Okay, so
Yeah.
okay,
Doctor, please, doctor, could you repeat that example again? Could you explain some more?
okay. So
Thank
if you multiply two vectors, if you multiply, but this is a dot product. It is called the two. It is a. It is not a, regular product. This is called the dot product. So dot product of two vectors: 1, 2, 3, 5, 6, 7. Dot. The notation is this dot. So it is the result is 1 times 5 plus 2 times 6 plus 3 times 7, 21. So the result is 38. So the result of a dot product of two vectors is is a scalar. Okay.
Sorry, doctor. Sorry for make you tired, but I meant from the beginning, from the
Okay.
first step. Yeah.
Okay. So this is exactly this is called the example asks us to compute ax, a times x.
سلام ورحمة الله.
So this is matrix A and this is vector x. So if
لا
we
منو جاي؟
we are going to multiply
حس أنت شيك أكتر.
a by this vector x, this means that multiplying the first column by this scalar. So this one goes through this one, and the second one goes through the second column, and the third scalar goes through the third column. So x1 times the first column, x2 times the second column, and x3 times the third column. And then you can actually have it like expand it: 2x1, 3x2, 4x3, and this is also the second row, and this is the third row. So if these are actually parameters, but if we had some numbers, we would be having some scalar at the end. Brother Tai says that y plus between that. Because this is actually brother. If you go back to this one, so this is what I just did. X1 is a scalar times a column plus x2 times second column and plus. So we have actually this plus between them, and then at the end we would be coming, we would be reaching to the final answer. This is a plus, the same plus, plus, and then we had this final answer, 2x1 plus 3x2 plus 4x3, and the second and third row. Okay, sure. Okay, so brother Hassan hopefully will. Okay, sure. Yes, of course. I You cannot access the you. Okay, so I will tell this to them, because the other guy who is in charge of handling these technical issues, he would be resolving this problem, hopefully, inshallah. Um, Actually, I don't have the number, because I was told that we will be fixing the problems in a couple of days. So they told me last week. So I was like, probably, hopefully by today everything has been resolved. But it seems that not. Yeah, some of them. But I think they have solved the problem for many of the students, and you will. No, I won't. Like I said, I won't be giving you um, exercises. You need to go through the assignments at the end of each subsection. You need to exercise them, and for the exam will be similar to them. The questions in the exam will be similar to them. If you are able to solve those problems, I promise that you would be able to solve the questions in the exam as well. No, I no. I mean, I just emphasized in the first sessions, and so I will be doing now, because the exam will be in person, not online through the internet. It won't be through the web. You need to travel here to Iran, and the exam will be in person. I was told that the exam won't be through the net.
Sorry, doctor, you want the final exam or this quiz?
I cannot do that because I was told that the exam has to be in person, not through the internet. I mean, see, I'm not the decision makers for this because the university they they uni, um I don't know exactly because the university. Okay, I will convey your voice to them.
Doctor, the university told us that the final exam is present in the university.
Okay, so
That's exactly this exam you mean?
uh, brothers,
نعم.
yeah, I will continue. I will be conveying your message to person who I know that probably I don't know if he's, yeah, but I'm not sure if he can solve the problem because he was also told that the exam will be in person.
ما خلى تشيككم يا ماشي وخابركم أبويا. هلا.
But after that you need to start the semester, which is the upcoming semester, which it starts in a month probably. You need to be here.
When, doctor? When you need to be here?
Okay, okay,
Next semester?
okay. So brothers, let me continue. I don't know exactly, but I will. Okay, sure. Um, so this is the rest of uh, that exercise. So we have one definition here: identity matrix. Identity matrix means a matrix which has one on its diagonal, and the rest elements are all zero. So one in the diagonal and zero elsewhere, anywhere else other than the main diagonal. So this is called the identity matrix. And we have these easy properties. If A is an m by n matrix, U and V vectors in Rn, and C is a scalar, A times U plus V. So pay closer attention, and U and V are vectors. And here U is a vector, but C is a scalar, A is a matrix. We are using this notation arrow, this arrow only for the vectors. So A times U plus V means is equal to AU plus AV. And A times CU equals to C times AU. Very easy. For the proof also, you can very easily prove that this holds. So we have this theorem number 5. If again formally AUV equals to AU plus AV, and A times CU, C times AU. The proof is very easy, but I won't be going through that in detail, but just as a hint, A times U plus V means if you write A as its columns, A means column A, this is the second column and third column, and for V, this was A, and if you write down U plus V as U plus V1, U2 plus V2, U3 plus V3, so these are scalars. And if you multiply this one, A times U plus V, and A2 times U2 plus V2, and A3 times A3 times U3 V3, we would be reaching to this one. You just need to be patient, and it's very easy to follow. And the second one also, the similar proof for that as well. So brothers, this was the fourth chapter, and this is the fifth chapter. So 1, 1, 1, 2, 1, 3, 1, 4, and this is 1.5 solution sets of a linear system. This is very important to know that a system of linear equations is said to be homogeneous if it can be written in the form of ax equals to 0. So the right side has to be 0, not any other number. Ax equals to 0. If we can write it down like this is called the homogeneous system. And so such a system, Ax equals to 0, always has at least one solution, brothers. Because x could be 0. Then A times x must be 0. So x equals to 0 is always one solution for that, the 0 vector. I'm not talking about 0 number. So because this is a matrix, for instance, A, B, C, D, and this has to be a vector, so 0 by 0. So this is x, and the result will be 0 and 0. So 0 is always one answer to this homogeneous equation. But this 0, because we already know that it has this answer, this is called the trivial solution. Trivial solution, which means it is very important to find it because we already know that it has a 0 solution. But the important question is to find non-trivial solution other than 0. Because A times x could be 0 and the vector x is non-zero. It could be non-zero. But still the result of this multiplication is 0. So when we are talking about the solution for this homogeneous equation, mainly we are referring to the non-trivial solution, not the trivial solution. So this is an example. Determine if the following homogeneous system has a non-trivial solution. This is a very important exercise. Then describe the solution set if it exists. Okay, so just refresh your mind. This is from the very first subsection that we had, 1.1. So 3x1 plus 5x2 minus 4x3 equals to 0. Minus 3, minus 2, minus 4, 0, and the same thing for the third one. So this is given. So the question is find the non-trivial solution for this. If you remember from the very first chapter, we are making the augmented matrix. Augmented matrix means A and 0 at the right for the last column, because see, this is the last column. All of them are 0. So this is a column, this is a column, and this is a matrix. Matrix A, and the last column is 0. So hopefully you remember the echelon form. So if we are going through this one, so this is matrix A. So this is matrix A, and this is the last column, 0. So if you remember from the echelon form, you can actually multiply one row by a number and then add it to another row. So for instance, if you add the first row to the second row, this becomes 0, 3, 0, 0. And if you multiply the first row by minus 2 and then add it to the third row, this makes this one 0. So 0, minus 9, 0, and 0. Again, adding the first row to the second row and then multiplying the first row by minus 2 and add it to the third row, we would be left with this matrix, and then again you can actually have some row operations, and then at the end we would be having this one. So the last row means 0, 0, 0, 0. This means 0 equals to 0. So this means that the system is consistent. Okay, so then for the first one, and also if you remember, this is the pivot position, and this is the pivot position, and the first column is a pivot column, and this is a pivot column, but the third one is not a pivot column. So this means that the third one, so this is x1, this is x2, and this is x3. I mean the first column, the second column, and the third column. So this means that the first column and the second columns are basic variables, and the third one is a free variable. So you can have it like any number, you can have any number for the third one. So for the echelon form, you can write it down, and you can write it down as this one. This is the third one. So if you divide the first column um, uh, if you continue this one, you will be reaching to this echelon form. 1, 0 minus 4 times by 3, and this is 0, and this is the second row and the third row. This is very easy, brothers. If you divide the third column by 3, this becomes 1. And then you can have this one times minus this times minus 5 and then add it to the first column, this 5 becomes 0, 2. If you multiply the second row by minus 5 and then add it to the first one, this becomes
Sorry, Doctor. The 5 number, how can 0?
وين بتكون؟
which one?
Yes.
No, which one? You are talking about which element, which row, which row?
5 by 3. Why happen 0?
هي مشاركة الآخر؟
Again, I didn't get that. Your voice is very loud. Just try to
بس خل
put
أخلص.
down the volume.
شوفوا إنه ماشي هتشغل
That's
صح.
very, very loud.
يعني
Instead 3. 5 in the first row.
Oh, okay.
How come it become be 0 when multiply the next row by 5 or minus 5? The first one be 0.
It is very
First-
important. So this
What
is the
happened?
okay. So brothers, let me explain that again. Just give me a second. Oh, I don't know exactly how to. Okay, so I removed everything. Okay, so let's do that again. Okay, so let's go back again. This was the equation that we were given. 3, 5 minus 4, 0. So look at these coefficients. Minus 3, minus 2, 4, 0. 6, 1, minus 8, 0. You remember the augmented matrix means putting these coefficients all together and the last column will be 0, 0, 0, 0. Okay, so this is called the augmented matrix. Okay, so now we have this one. This is matrix A, matrix of coefficients A, and this is column 0 because this is a homogeneous equation. Okay, so for the brothers and sisters who were not probably present in the first 2 or first sessions, we are allowed to use some row operations. What does it mean? It means that you can add one row to another row and then replace the results for the last one. For instance, here, if you add the first row plus the second row, we have this one 0, this becomes 0, this becomes 3, and this will be 0. So this is the result. And then if you multiply the first row by minus 2, and then add it to the third row, so this becomes minus 6, which makes this one 0, and minus 2 times 5 becomes minus 10, plus 1, it becomes minus 9, and then minus 2 minus 4, 8, 8 minus 8 becomes 0. So this is the third row, right? And then we can continue. I mean, we can go through this in many ways. For instance, if you multiply the second row by minus 5 by 3, minus 5, see brothers, minus 5 by 3. if you multiply that number to the second row, this makes this one minus 5. And then you can have it, you can add it to the first row, which makes this one 0. 5 becomes 0. Okay. And then if you divide the second, if you can do something. If you multiply the second row by 3 and then add it to the third one, this makes this one 0, right? Because 3 by 3 becomes 9. So if you add 2 minus 1, this makes this one 0. And it doesn't change the other elements because all of them are 0. So this becomes 0 and this becomes 0. And then if you divide the second row by 3, this makes this one 1. Okay, this is very easy. So this is 1, these two are 0, and the rest are 0. And for the first one, because this was 3 and minus 4, if you divide all of these row by 3, this becomes 1, and this is minus 4 minus 4 by 3. And this is the final results. And again, brothers, this is a pivot position because this is the leftmost element, non-zero element in this row. Because so this is a pivot position, and the leftmost non-zero element in the second row is this one. So this is also a pivot. So pivot, and we won't be having any other pivots. So this means that the first column and the second column are two basic variables, which corresponds to x1 and x2. But the third column, which corresponds to x3, is a free variable. So if you change this one to linear equation notation, this becomes x1. For x2 it is 0, so x1 minus 4 by 3 x3 becomes 0. And for the second one, x2 is 0, and for the third one, this is a consistent equation, so it doesn't change anything. So x2 is 0, x1 minus 4 by 3 x3 is 0, so you can actually have this one. x1 equals to 4 by 3 x3. Okay, that's it. So the final answer will be right.
Please, doctor.
Okay.
The last step. If we repayment x3 0 by the first row, then x1 it becomes 0, right?
x1, no. Which part?
If I repayment x3 0 equal to 0, right?
Okay, so this means the system is consistent.
Okay, that's great. So if can we repayment this 0 on the first row, then 4 divided by negative 4 divided by 3 multiply 0, then it will be 0. So x1 will be equal.
No, you cannot multiply this one with a 0. You can actually multiply this with a non-zero number.
No, I meant repayment x3 on the first row, not divided all the row first row. I meant this 0 equal to 0, right?
Okay.
x3.
Okay. So
if I repayment this one on the first row. So I meant
First
my
row.
meaning, yeah, my meaning x3 if I repayment 0 on x3. So
X3.
it will be,
No, so brother, X3 is this one, this column.
yes.
Okay,
Guys.
so what should I do then?
Can I repayment the x3 value on the first row? Then it will be negative 4 divided by 3 multiply 0.
No, I just said that you cannot multiply this one. No, no. I mean, why you are going to do that? Because x3 is not 0. Why you are going to multiply minus 4 by 3 by 0?
So that's impossible, huh?
No, it is impossible, of course. No, x3 is a free variable. This means
So
that
maybe
no, these
uh-huh.
are these two x1 and x2 are basic variables, and x3 is a free variable, and x1 equals to x4 by 3 x3. So you can replace x3 with any number that you would like. You can actually have a solution. So the final answer is this one, x equals to x1, x2, x3, and you can replace x1 with this one, 4 by 3 x3. So this is x1, and this is x2, and this is x3. This is a free variable, and if you factorize x3, the final answer will be x3 by 4 by 3, 0, and 1. So this is the final answer.
final answer هاي.
So this is called the answer for the homogeneous linear systems. So like I just said, this is the span of V. For instance, if the vector V is represented by this arrow, this is V, the span will be on this line. If you go further and back, all of them are a span of V. And actually, we can have some other exercises, but I can continue this one tomorrow morning. Okay, so this is slide number 6. We will continue from this slide. But brothers, I will do something. I will send brother Hassan in a second an email. No, I can do something else actually. No, brothers, look, I mean, this is even easier. So I will upload some lectures here. Just note the address that I will be writing in a second. http e so everyone please try this address, say ir tilde nazarfal la.pdf. This is a book. Can we
دكتور
get
دكتور.
more explain to the last lecture, please? Which lecture you are talking about?
Do you hear me, دكتور?
Yes, I do hear you.
Is it? We get it, the book and all the lecture. If and I sent to other students in Telegram group where they
No.
all there. I will send Telegram link of Telegram group here, doctor. Okay.
You have the all of the. No, brothers. Someone needs to make your microphone off, please. Someone needs to make it off. No, brothers.
Ready.
Someone has to make his microphone off.
اخوان طفوا المايك اخوان.
I sent Telegram group here in chat, doctor, where all lectures and book and everything here. If any students can enjoy to this Telegram group, can say all lectures and book here.
Okay, that's great. If you have all of the lectures, that would be awesome.
Okay,
That's great.
we have it, doctor. Thank you very much.
Okay, no problem. I was going to do that for. So all of them. The sister just I don't know her name, but one of the sisters said that I think maybe she doesn't have or any other student. So all of you can go through the Telegram group. Yeah. Brother Shabab Hussein, Shorfa, Khuya. Yeah, I got it. So we will continue tomorrow morning. Tomorrow we will be having the session very early in the morning, before 8. And then some of the brothers needs to turn off his microphone. Okay, so tomorrow we will continue this discussion. Brothers, have a good time. Thank you so much.
Thank you, doctor.
Thank you,
Thank you.
doctor.
Thank you,
Have a
doctor.
good night.
So
Thank
much.
you, doctor, for your patience. Thank you so much.